Hello everyone, I'm Yazan Ibrahim, or as some of you might know me, Yazan Abu Ghosh. Today we're going to dive into a fascinating and essential topic. Welcome. Having journeyed through the foundational domains of AI governance and risk in Part 1 and the operational intricacies of AI operations in Part 2, we now embark on Part 3, AI auditing tools and techniques. Our first stop in this critical domain is Chapter 13, Audit Planning and Design. Effective audit planning and design are absolutely foundational to conducting a successful, impactful, and efficient AI audit. This initial phase is paramount. It involves developing a deep understanding of the organization's AI landscape, systematically identifying all relevant AI assets and the controls governing them, clearly defining the audit's scope and precise objectives, and crucially, ensuring that the audit team possesses the necessary competencies and skills to navigate the complexities of AI. Without meticulous planning, an AI audit risks being unfocused, inefficient, or failing to address the most critical AI-related risks and opportunities. The principles we'll discuss in this chapter for planning and designing AI audits are not created in isolation. They are grounded in established audit methodologies and frameworks, such as those promoted by ISACA and the IIA, and are being adapted to the unique context of artificial intelligence. Furthermore, considerations for AI-specific risks and governance are increasingly highlighted in broader frameworks like the NIST AI Risk Management Framework, AIRMF, and international standards such as ISO IEC 42001 for AI management systems. So let's explore how to lay the perfect groundwork for a robust AI audit. Section 13.1, Identification of AI Assets. The very first crucial step in planning any AI audit is to comprehensively identify and inventory all AI assets within the organization. It's important to understand that auditing AI requires a holistic view that extends far beyond just the model algorithm itself. It encompasses a wide array of interconnected components. Importance of identifying AI assets. Why is this identification process so critical? Several reasons. Scope definition. A clear inventory of AI assets helps to precisely define the boundaries and scope of the audit engagement. It clarifies which systems, models, data sources, and processes will be included or excluded from the audit. Risk assessment. Understanding the portfolio of AI assets allows auditors to identify those systems that are critical to business operations, those that handle sensitive or personal data, or those that pose significant ethical or compliance risks. This information is fundamental for informing the audit risk assessment and helps prioritize audit efforts on the areas of highest concern. Control identification. Different AI assets will have different associated controls designed to govern them and mitigate risks. Identifying the assets is therefore a necessary prerequisite for subsequently identifying and evaluating the effectiveness of these pertinent controls. Resource allocation. Knowing the number, complexity, and nature of AI assets helps in allocating appropriate audit resources. This includes audit hours, budget, and ensuring personnel possess the specific AI expertise required. Compliance verification. Certain AI assets may be subject to specific legal or regulatory requirements, for instance, high-risk AI systems under the EU AI Act. Identifying these assets ensures they are included in compliance checks and that the audit addresses relevant obligations. Understanding AI footprint. Understanding AI footprint. This process provides the audit team, and indeed the organization, with a holistic view of how and where AI is being used across various departments and functions. This comprehensive understanding is essential for strategic audit planning and for providing valuable advice to management on AI governance. Types of AI assets. Auditors should look for a broad and diverse range of assets that are associated with the entire AI lifecycle. These include AI models, trained models. These are the actual machine learning or deep learning models that have been trained and are either deployed in production or are ready for deployment. Examples include classification models, regression models, natural language processing, NLP models, computer vision models, and generative AI models. Pre-trained models. These are models that have been sourced from third parties, such as cloud providers or open source repositories like Hugging Face. Organizations often use these as a base and then fine-tune them with their own data. Model algorithms and architectures. The underlying algorithms, e.g. in decision trees, neural network architectures, and the specific architectural designs chosen for the AI models are themselves key assets. Model parameters and weights. The learned parameters and weights that define a trained model's specific behavior and decision-making capabilities are critical components. Data assets for AI, training data. These are the data sets used to train the AI models. This includes the raw data collected and any labeled or annotated data derived from it. Special attention must be paid to its quality, representativeness, and potential biases during the audit. Validation data. These data sets are used during the model development process to tune model hyperparameters and make interim assessments of performance. Test data. These are holdout data sets unseen by the model during training, used for the final evaluation of the model's performance and generalization capabilities before deployment. Input data, operational data. This is the live data fed into deployed AI models for real-time or batch inference and decision-making. Output data, predictions, decisions. The results, predictions, classifications, or decisions generated by the AI models are also important data assets. Metadata. This includes data describing other data such as data dictionaries, schemas, information about data lineage or provenance, data quality metrics, and labeling guidelines. Metadata is crucial for understanding and governing AI data. AI software and tools, development platforms and frameworks. The software environments and libraries used to build and train AI models such as TensorFlow, PyTorch, Scikit-learn, or cloud-based AI platforms like AWS, SageMaker, Google Vertex AI, and Azure Machine Learning MLOps tools. These are platforms and tools specifically used for managing the entire machine learning lifecycle. This includes capabilities for version control of models and data, continuous integration and continuous deployment, CI/CD for models, automated monitoring and retraining. Data annotation and labeling tools. Software used to label or annotate data, which is a critical step for supervised learning approaches. AI-specific libraries and packages. Specialized software libraries and packages utilized in various stages of AI development, such as those for data analysis, visualization, or specific AI algorithms. AI infrastructure, hardware. This includes specialized hardware often used for AI training and inference due to their computational demands, such as graphics processing units, GPUs, tensor processing units, TPUs, and other AI-optimized servers. Cloud resources, cloud computing services, infrastructure as a service, IaaS, platform as a service, PaaS, software as a service, SaaS, that are utilized for AI development, model training, deployment, and data storage. Data storage systems, the databases, data lakes, data warehouses, and other systems used for storing the vast amounts of AI-related data. AI documentation and knowledge assets, model cards, or fact sheets. These are documents that summarize a model's key characteristics, its performance metrics, known limitations, intended use cases, and important ethical considerations. Data sheets for datasets. Documents that describe datasets, detailing their sources, collection methods, statistical properties, any known biases or limitations, and recommended uses. Design documents, specifications outlining the AI system architecture, model design choices, and data flow diagrams. Risk assessments. AI-specific risk assessments, such as AI impact assessments, AIAs, bias assessments, or security risk analyses. Policies and procedures, formal AI governance policies, data handling procedures, ethical AI guidelines, and incident response plans specific to AI. Training materials, documentation, and materials related to the AI systems themselves and their proper operation or use. Human capital related to AI. While not an asset in the traditional IT sense, the skills, knowledge, and expertise of personnel involved in AI, such as data scientists, ML engineers, AI ethicists, domain experts, and ML ops professionals, are critical organizational resources essential for AI success. An audit might consider the adequacy and management of these human resources as part of the overall AI capability. AI-powered applications and systems. These are the end-user applications or broader enterprise systems that embed or utilize AI models to provide specific functionalities or automate processes. Methods for identification of AI assets. Auditors can employ several methods to comprehensively identify these AI assets. Interviews and workshops. Engaging in detailed discussions with key stakeholders across the organization. This includes AI development teams, data science units, IT departments, business unit leaders who use or are planning to use AI, risk management personnel, legal and compliance officers, and ethics teams. Reviewing documentation, thoroughly examining strategic plans related to AI, project documentation for specific AI initiatives, system architecture diagrams, existing data inventories or catalogs, software inventories, and any AI governance documentation that exists. The Integrated Artificial Intelligence Framework itself highlights the importance of documenting resources required for various AI system lifecycle stages, which can serve as a source for auditors. Surveys and questionnaires. Distributing targeted surveys or questionnaires to relevant departments or personnel to gather standardized information about AI usage, known AI systems, datasets used for AI, and associated tools across the organization. Automated discovery tools utilizing IT asset management tools, software inventory tools, data discovery tools, and potentially specialized AI governance platforms that may have capabilities to help identify AI models, data sets, and related software components used within the IT environment. Leveraging existing inventories, checking existing organizational resources such as comprehensive data inventories, application portfolio management systems, and general IT asset registers, and then specifically identifying AI-related components within them. Analyzing code repositories. For internally developed AI solutions, analyzing code repositories, e.g., Git, can reveal the use of common AI libraries, frameworks, and model development activities. Maintaining an AI asset inventory. Once AI assets are identified, they should be cataloged in a dedicated AI asset inventory or register. This inventory should not be a static document. It must be treated as a living resource that is regularly updated as new AI systems are developed, existing ones are modified or retired, and as the AI landscape within the organization evolves. At a minimum, this inventory should include key information for each asset, such as asset name or identifier asset type, e.g., model, dataset, tool, infrastructure component, a clear description of the asset and its purpose, designated owners, both business and technical owners, assessed criticality or sensitivity, level of the asset, data sources used or generated by the asset, current deployment status, e.g., in development, testing, production, retired, a link to relevant documentation, e.g., model card, design document, risk assessment, a summary of associated risks and key controls in place. A comprehensive understanding and a well-maintained inventory of AI assets are crucial first steps in effective AI audit planning. This allows the audit function to appropriately scope engagements, accurately assess risks, and focus testing efforts on the areas that matter most, ultimately providing valuable assurance and insightful advice to the organization regarding its AI initiatives. Section 13.2. Types of AI controls. After identifying the organization's AI assets, the next critical step in audit planning and design is to understand the various types of controls that should be in place. These controls are designed to govern AI assets, manage the associated risks, and ensure that AI systems operate reliably, ethically, and in compliance with both organizational policies and external regulations. Effective AI risk mitigation relies heavily on a multi-layered control environment that addresses the unique challenges posed by AI. AI controls are the policies, procedures, practices, and organizational structures specifically designed to provide reasonable assurance that AI objectives will be achieved and that undesired AI-related events will be prevented, detected, or corrected in a timely manner. These controls can be categorized in several ways, often mirroring traditional IT control frameworks, but with specific adaptations and additions necessary to address the unique characteristics and risks of AI. The Integrated Artificial Intelligence Framework, as per the provided docx source, provides a basis for understanding these by discussing key controls over AI management systems and key controls in the AI system lifecycle. Categories of AI controls. Let's explore some key categories: governance and oversight controls. Focus. These controls establish the overall framework for managing and overseeing AI within the organization. They are designed to ensure clear accountability, strategic alignment of AI initiatives with business goals, ethical guidance, and robust risk management oversight for all AI activities. Examples: AI Governance Framework, a formally documented and approved framework that outlines roles, responsibilities such as those defined in ISO IEC 38507 for governance implications, decision-making processes, reporting lines, and oversight mechanisms for AI. This might include AI steering committees, dedicated AI ethics boards, or councils. AI policies and standards, a hierarchy of formal, approved policies addressing responsible AI development and use, data governance specific to AI, articulation of AI ethics principles, AI risk management methodologies, and procedures for ensuring compliance with relevant AI laws and standards, e.g., a comprehensive AI policy as emphasized in ISO IEC 42001. Ethical AI principles and guidelines. Clearly defined, communicated, and embedded ethical principles, e.g., fairness, transparency, accountability, non-maleficence, human oversight, that must guide all AI development and deployment activities across the organization. AI risk management framework, a structured and repeatable process for identifying, assessing, evaluating, treating, monitoring, and reporting on AI-specific risks. This framework should be integrated with the broader enterprise risk management (ERM) program and align with recognized standards like ISO IEC 23894, AI risk management, or the NIST AI RMF. Regulatory compliance, monitoring, and adherence, processes and controls designed to proactively track evolving AI laws and regulations, e.g., the EU AI Act, data privacy laws like GDPR, and to ensure that organizational AI practices remain consistently compliant. Defined roles and responsibilities for AI, clearly documented and assigned roles for AI strategy, management, development, operations, data stewardship, ethical review, risk management, and audit. This includes roles such as AI manager, AI data science manager, AI risk manager, AI compliance manager, and AI ethics manager as outlined in the IIP framework. Stakeholder engagement and communication mechanisms. Formal processes for engaging with internal stakeholders such as employees and different departments, and external stakeholders such as customers, regulators, and the public regarding AI initiatives, their potential impacts, and ethical considerations. This should also include mechanisms for grievance and redress for those adversely affected by AI systems. AI strategy alignment. Controls to ensure that all AI initiatives are demonstrably aligned with the overall business strategy and objectives of the organization, ensuring AI drives value and supports strategic goals. AI System Development Lifecycle (SDLC), MLOps controls. Focus. These controls are designed to ensure that AI systems are designed, developed, tested, validated, and deployed in a controlled, secure, ethical, and responsible manner, consistently adhering to established quality standards and development methodologies. Examples: requirements definition and management, controls over the process of defining, documenting, approving, and managing functional requirements, non-functional requirements such as performance, security, usability, as well as ethical and compliance requirements for all AI systems. Secure design and development practices, DevSecOps for AI. The integration of security and privacy by design principles directly into the AI development process from its earliest stages. This includes conducting threat modeling specific to AI systems, adhering to secure coding practices for AI components and algorithms, and implementing robust vulnerability management throughout the lifecycle. Algorithm selection, justification, and validation, controls governing the choice of AI algorithms and models, ensuring they are appropriate for the intended task and data, that their selection is justified, that they are validated for performance against clear metrics, and that their inherent limitations are well understood and documented. Model validation and rigorous testing procedures, comprehensive and rigorous testing of AI models for accuracy, robustness, e.g., against adversarial inputs or noisy data, fairness, potential biases, and security vulnerabilities before they are deployed into production environments. This encompasses both conventional software testing techniques adapted for AI and AI-specific testing methodologies. Change management for AI models and systems. Formal processes for managing all changes to AI models, such as retraining, updates to architecture, or hyperparameter tuning, data pipelines, and associated software components. This includes maintaining version control for models, datasets, and code to ensure reproducibility and traceability. Comprehensive documentation standards. Requirements for thorough, accurate, and consistent documentation of AI systems throughout their life cycle. This includes model cards which summarize model characteristics, performance, limitations, and ethical considerations, data sheets for data sets, detailing provenance, collection methods, known biases, detailed design specifications, and comprehensive test results, verification and validation (V&V) processes, independent checks, reviews, and tests conducted at various critical stages of the AI SDLC to ensure the AI system meets its specified requirements, functions as intended, and that implemented risk mitigation measures are effective before operational deployment. Data management and governance controls for AI focus. These controls are absolutely paramount for AI, as AI systems are fundamentally data-driven. They ensure the quality, integrity, security, privacy, and ethical handling of all data used throughout the entire AI lifecycle, from initial collection and preparation to training, live operation, and eventual secure disposal. Examples: data governance framework for AI, specific policies, procedures, standards, and defined roles dedicated to the governance of data used in AI systems. This includes strategies for ethical data acquisition, comprehensive data quality management frameworks, robust data lineage tracking capabilities, metadata management standards, and data retention deletion policies tailored to the specific needs and risks of AI datasets. Data quality assurance and validation processes and technical measures to ensure that data used for training, testing, and operating AI systems is accurate, complete, consistent, timely, relevant, and crucially representative of the target population to avoid unfair biases. This includes techniques for actively detecting and mitigating biases present in datasets. Data security and confidentiality controls, robust technical and procedural measures designed to protect all AI data, both training data and operational data, from unauthorized access, use, disclosure, alteration, or destruction. This includes implementing data classification schemes, strong encryption at rest and in transit, granular access controls, and conducting regular security audits of data stores. Data privacy controls, mechanisms to ensure full compliance with applicable data privacy regulations such as GDPR, CCPA, when using personal or sensitive data in AI systems. This includes processes for obtaining valid consent where required, implementing data minimization principles, employing anonymization or pseudonymization techniques appropriately, and conducting data protection impact assessments (DPAs) for high-risk AI processing activities. Data provenance and lineage documentation, systematically tracking and documenting the origin, history, and all transformations of data used in AI systems. This is critical for ensuring traceability, auditability, understanding potential data quality issues, and building overall trustworthiness in the AI system. AI model operational and monitoring controls, often part of MLOps. Focus. These controls ensure that once AI models are deployed, they operate reliably, securely, ethically, and effectively in the production environment throughout their entire operational lifespan. Examples: standardized deployment controls, formal, repeatable, and audited procedures for deploying AI models into production environments. This includes pre-deployment checklists, robust configuration management for models and infrastructure, and well-tested rollback plans in case of deployment failures. Continuous performance monitoring, ongoing, real-time or near real-time monitoring of AI model accuracy, latency, throughput, error rates, and other key performance indicators (KPIs) against established baselines and acceptable thresholds. Drift detection and management, data and concept drift, implementing controls and automated tools to detect statistically significant changes in the input data distribution data drift, or in the underlying relationships between inputs and outputs that the model learned, concept drift. These controls should trigger alerts or automated model retraining recalibration processes when significant drift is identified to maintain model performance. Security monitoring for deployed AI systems, actively monitoring deployed AI systems for AI-specific attacks such as adversarial inputs, model extraction attempts, or data exfiltration, and any anomalous behavior that could indicate a security compromise or misuse. Human oversight and intervention mechanisms, designing and implementing clear processes and user interfaces that allow for meaningful human review, intervention, or the ability to override AI-driven decisions, especially in high-risk, safety-critical, or ethically sensitive scenarios where human judgment is indispensable. Comprehensive logging and auditing of AI decisions and actions, maintaining detailed, immutable logs of AI model inputs, the outputs, or decisions generated, key internal decision parameters where feasible for explainability, confidence scores associated with outputs, and any actions taken by the AI system. This detailed logging is crucial for traceability, debugging, incident investigation, compliance, and audit purposes. AI-specific incident response plan, having well-defined, documented, and tested procedures specifically for responding to various types of incidents involving AI systems, e.g., sudden critical model failure, detection of severe ethical bias in outputs, security incidents targeting AI assets, or safety events. Ethical, societal impact, and trustworthiness controls focus. These controls are designed to proactively manage the broader ethical implications and potential societal impacts of AI systems, and to ensure their overall trustworthiness in alignment with human values. Examples: bias detection, mitigation, and fairness. Assurance techniques, implementing techniques and processes throughout the AI lifecycle, from data collection and preparation through model development and ongoing monitoring, to identify, measure, and actively reduce unfair bias in AI model behavior and outcomes across different demographic groups or protected characteristics. Explainability and transparency mechanisms, XAI, implementing and validating tools and methods, e.g. LIME, SHAP, model-specific explainers, clear model cards, to provide understandable explanations for AI model decisions tailored to the needs of different stakeholders such as developers, users, customers, regulators, and auditors. This is key for building trust, as outlined in ISO IEC TR 24028. Mechanisms for redress, appeal, and contestation. Establishing clear, accessible, and effective processes for individuals to challenge, seek review of, or appeal AI-driven decisions that significantly affect them, especially if those decisions are perceived as erroneous, unfair, or harmful. Public communication, transparency reports, and stakeholder dialogue, providing clear and accessible information to the public and other relevant stakeholders about how the organization develops, deploys, and uses AI, and how it manages the associated risks and ethical considerations. This can include publishing AI ethics statements, transparency reports, or actively engaging in dialogue with affected communities. These various types of AI controls are often interconnected and should be implemented as part of a cohesive and comprehensive AI management system, AMS, such as one aligned with the principles and requirements of ISO IEC 42001. During an AI audit, auditors will seek to identify these controls, assess their design adequacy in relation to the specific AI assets and identified risks, and test their operating effectiveness to provide assurance to management and other stakeholders. The selection and rigor of these controls should always be proportionate to the risks posed by the specific AI system being considered. AI audit use cases delineate specific scenarios, AI applications, AI systems, or distinct aspects of AI governance and operations that become the focal point of an audit engagement. Identifying and clearly defining these use cases is a critical part of audit planning and design. It helps auditors to precisely define the scope and objectives of their work, tailor their audit programs effectively, and allocate resources efficiently to the areas of greatest risk or importance. AI audit use cases can vary widely, from conducting a deep technical audit of a single high-risk AI model to performing a broad strategic assessment of the entire AI governance framework across an organization. Common AI audit use cases. Let's explore some common examples. Audit of AI model development and validation processes. Focus: assessing the rigor, reliability, and adherence to internal standards and external best practices in the processes used to develop, train, test, and validate a specific AI model or a portfolio of models. Typical activities: reviewing methodologies for data collection and preparation, including data quality checks and bias assessments, evaluating algorithm selection criteria and justification, examining model training procedures and hyperparameter tuning processes, scrutinizing testing strategies, including the use of AI-specific tests for robustness, fairness, and security, assessing validation techniques against predefined performance metrics, and reviewing the quality and completeness of model documentation like model cards and development logs. Relevance: this use case ensures that AI models are built on a sound technical foundation and are verified as fit for their intended purpose before deployment and throughout their operational life. It aligns with the lifecycle management aspects of ISO IEC 42001 and ISO IEC 23053. Audit of AI bias, fairness, and non-discrimination. Focus: evaluating an AI system for potential unfair biases and discriminatory outcomes across different demographic groups or legally protected characteristics, e.g. the race, gender, age, disability. Typical activities: analyzing the representativeness and potential biases in training data sets, testing model outputs using various quantitative fairness metrics such as demographic parity, equalized odds, equal opportunity, or predictive rate parity, reviewing the effectiveness of bias detection and mitigation techniques implemented during development and operation, and assessing the transparency of fairness considerations and decisions in the overall AI lifecycle. Relevance: this is critical for upholding ethical AI principles, ensuring compliance with anti-discrimination laws and emerging AI regulations like the EU AI Act, and maintaining the trust of users and the public. This resonates strongly with ethical considerations outlined by NIST and ISACA. Audit of data governance and management for AI. Focus. Assessing the effectiveness of controls and processes governing the data used throughout the entire AI system lifecycle. This includes data quality, integrity, security, privacy, and the ethical sourcing of data. Typical activities: reviewing policies and procedures for data sourcing and acquisition, including consent mechanisms for personal data, evaluating data quality management processes, ensuring accuracy, completeness, consistency, assessing data labeling and annotation accuracy, examining data security measures like encryption, access controls, data classification, verifying data privacy compliance, e.g., use of anonymization or pseudonymization techniques, completion of DPIAs, scrutinizing data lineage tracking, and reviewing data retention and deletion practices specific to AI datasets. Relevance. This use case ensures that the fundamental input to AI systems data is sound, secure, and responsibly managed, which directly impacts model performance, reliability, and trustworthiness. Audit of AI system security and resilience. Focus. Evaluating the security posture of AI systems, including their protection against both conventional cybersecurity risks and emerging AI-specific threats, as discussed in Chapter 11. Typical activities: assessing controls designed to prevent and detect data poisoning attacks, model evasion, adversarial examples, model stealing or extraction, and privacy invasive attacks like membership inference or model inversion. This also involves reviewing access controls to AI models, training data and inference APIs, evaluating the security of AI development and deployment infrastructure, including MLOps pipelines, and assessing the adequacy of incident response plans tailored for AI-specific security breaches. Relevance: this protects valuable AI assets, models, and data, ensures the integrity and availability of AI services, and mitigates a wide range of security-related risks that could undermine AI systems. Audit of AI ethics, responsible AI practices, and societal impact. Focus. Assessing the alignment of an organization's AI systems, development practices, and operational procedures with its stated ethical AI principles, societal values, and broader responsible AI guidelines. Typical activities: reviewing ethical impact assessments, like those described in ISO IEC 42005, conducted for AI projects, evaluating the implementation and effectiveness of transparency and explainability mechanisms, XAI, examining procedures for ensuring meaningful human oversight where required, assessing accountability frameworks for AI-driven decisions, and verifying the availability of mechanisms for redress or appeal for individuals adversely affected by AI systems. Relevance. This use case ensures that AI is developed and deployed in a manner that is trustworthy, beneficial to society, and minimizes potential harm, aligning with guidance from NIST AI, RMF, and international ethical frameworks. Audit of AI regulatory compliance, e.g., EU AI Act, GDPR. Focus: verifying the compliance of AI systems and related organizational processes with all applicable local, national, and international laws, regulations, and industry-specific standards. Typical activities: assessing adherence to specific requirements for high-risk AI systems, e.g., under the EU AI Act. This includes risk management systems, data governance, technical documentation, transparency, human oversight, accuracy, robustness, and cybersecurity. Reviewing compliance with data protection regulations, e.g., GDPR or CCPA, in the context of how AI processes personal data, and any sector-specific AI rules, e.g., in finance or healthcare. This involves reviewing documentation, risk assessments, conformity assessment procedures, if applicable, and post-market monitoring activities. Relevance: this helps the organization avoid legal penalties, maintain market access, especially in regulated jurisdictions like the EU, and demonstrate due diligence and corporate responsibility. Audit of AI governance framework, e.g., AMS audit based on ISO 42001. Focus: assessing the overall design, adequacy, and operating effectiveness of the organization's AI management system, AIMS, or its comprehensive AI governance framework. This is often a holistic audit that looks at the entire system of managing AI within the organization. Typical activities: reviewing documented AI policies and standards, evaluating the clarity and effectiveness of defined roles and responsibilities for AI as per ISO IEC 38507, examining AI risk management processes, scrutinizing SDLC controls specific to AI development, assessing AI-related training and awareness programs, evaluating mechanisms for monitoring and review of AI systems, and reviewing stakeholder engagement practices. The audit would assess the alignment of these elements with established standards like ISO/IS 42001 or comprehensive frameworks like the NIST AI-RMF. Relevance. This provides comprehensive assurance on the organization's capability to manage AI strategically, ethically, and responsibly across all its operations, and is fundamental for achieving certification against standards like ISO/IEC 42001, which itself can be audited by bodies compliant with ISO/IEC 42006. Audit of third-party AI risk management. Focus: evaluating the risks associated with AI solutions, components, pre-trained models, or data sourced from external third-party vendors or partners. Typical activities: reviewing the organization's due diligence processes for selecting and onboarding AI vendors, assessing the adequacy of contractual agreements including SLAs, security requirements, privacy obligations, and audit rights, evaluating the vendor's own compliance certifications and security posture, and examining the ongoing monitoring of third-party AI performance, security, and compliance. Relevance: this is crucial for managing risks introduced through the increasingly complex and often opaque AI supply chain. Audit of AI model explainability and interpretability (XAI). Focus: assessing the effectiveness, accuracy, appropriateness, and understandability of the methods and techniques used to explain AI model decisions to various relevant stakeholders. Typical activities: reviewing the specific XAI techniques employed, e.g., LIME, SHAP, feature importance analysis, rule extraction, evaluating the clarity, fidelity, how faithfully the explanation represents the model's actual reasoning, and usefulness of the explanations generated for different target audiences, e.g., AI developers for debugging, business users for decision support, customers for transparency, regulators for compliance purposes. This also involves verifying that explanations accurately reflect model behavior and do not inadvertently reveal sensitive or confidential information. Relevance: this use case is crucial for building trust in AI, enabling transparency, facilitating debugging and model improvement, ensuring accountability for AI decisions, and meeting increasing regulatory demands for explainable AI. Audit of AI operational resilience monitoring and MLOps practices. Focus: assessing the ability of deployed AI systems to maintain their performance, reliability, and integrity over time in the dynamic production environment. This includes evaluating the effectiveness of machine learning operations, MLOps practices. Typical activities: reviewing processes for continuous model monitoring, which includes checking for performance degradation, data drift, concept drift, and potential security anomalies, examining strategies and triggers for model retraining or recalibration, inspecting model versioning and rollback capabilities, evaluating incident response procedures for AI operational issues, and assessing the overall governance and efficiency of the MLOps pipeline. Relevance: this ensures that AI systems remain effective, reliable, and secure throughout their entire operational lifespan, adapting to changing conditions and consistently maintaining their intended value. These AI audit use cases are often interconnected and may be combined within a single broader audit engagement depending on the specific audit objectives and overall scope. The particular use cases selected for an AI audit will typically be driven by the organization's AI maturity level, the criticality and risk profile of its AI systems, the findings of the organization's own AI risk assessments, and the strategic objectives of the audit function and the wider organization. Section 13.4. Internal training for AI use. Internal training and comprehensive awareness programs are absolutely indispensable for ensuring that employees at all levels and across various functions within an organization develop a sound understanding of artificial intelligence. This understanding should encompass AI's vast potential benefits, its inherent and often complex risks, clarity on their specific roles and responsibilities concerning the ethical and compliant use of AI, and familiarity with the organization's established AI governance framework, its policies, and its guiding ethical principles. Such training is a critical organizational control for managing human-related risks in the adoption and scaling of AI. Assessing the adequacy and effectiveness of these internal training programs is therefore a critical audit activity. This directly aligns with the awareness Clause 7.3 and Competence Fund Clause 7.2 aspects of the support requirements in management system standards like ISO IEC 42001 and strongly resonates with the education component P4 of the OCEG GRC capability model. Importance of internal training for AI use within organizations. Effective internal training programs for AI serve multiple vital purposes. Promote responsible and ethical AI use, educating employees on core ethical AI principles such as fairness, transparency, accountability, non-maleficence, potential sources and impacts of algorithmic bias, and appropriate use cases for AI, helps to foster a deeply ingrained culture of responsibility and ethical mindfulness in all AI-related activities. Enhance AI literacy across the workforce, improving the overall understanding of fundamental AI concepts, drawing from ISO IEC 22989 on AI concepts and terminology, common machine learning techniques, AI capabilities, and crucial limitations across the entire workforce, not just within specialized technical teams. This empowers more employees to identify opportunities for AI and to interact with AI systems more effectively and critically, ensure compliance with regulations and policies, making all relevant employees thoroughly aware of applicable AI-related laws and regulations, e.g., EU AI Act, data privacy laws like GDPR, internal AI governance policies, data handling procedures, and their specific compliance obligations when working with or using AI systems. Mitigate human error and misuse, reducing the risk of incidents, errors, or negative outcomes caused by unintentional misuse of AI systems, misinterpretation of AI-generated outputs, or incorrect operation of AI tools due to lack of understanding or training. Support effective AI adoption and integration, increasing employee comfort, confidence, and competence in using AI tools and integrating AI-driven insights into their daily workflows. This leads to better adoption rates, more effective utilization of AI solutions, and ultimately greater value realization from AI investments. Enable proactive identification and reporting of AI issues, empowering employees at all levels to better recognize potential AI-related problems, such as unexpected model behavior, potential ethical concerns, e.g., observed bias, data quality issues, or security vulnerabilities, and to know the correct channels for reporting these issues promptly. Facilitate productive human-AI collaboration, training employees on how to effectively collaborate with AI systems, understanding how AI can augment their capabilities, and how to provide valuable feedback to improve AI performance or address its shortcomings. This aligns with understanding different models of human-AI cooperation. Key components of a comprehensive internal AI training program. Effective internal AI training programs should be multifaceted and carefully tailored to the specific needs and roles of different audiences within the organization. General AI awareness training, mandatory for all employees. Content should cover basic concepts of artificial intelligence and machine learning, what AI is and isn't, common AI applications relevant to the organization and its industry, a balanced view of the high-level benefits and potential risks of AI, an overview of the organization's established AI ethics principles and overarching AI policy, fundamental data privacy considerations related to AI, and clear channels for raising AI-related questions or concerns. Objective: to create a baseline understanding, demystify AI, and promote a common language and awareness of AI across the entire organization. Role-specific AI training, targeted and in-depth. For AI developers, data scientists, and ML engineers, in-depth technical training on secure AI development practices, security by design, advanced techniques for bias detection and mitigation, robust model validation and testing methodologies, MLOps principles for managing the AI lifecycle, specific data governance requirements for AI, ethical AI by design principles, and AI-specific vulnerability testing for business users, managers, and decision makers who interact with AI systems. Practical training focused on how to effectively use specific AI tools and applications relevant to their job functions, how to correctly interpret AI-generated outputs, insights, and confidence scores, understanding the inherent limitations and potential failure modes of the AI models they use, knowing when and how to seek human oversight or override AI suggestions, and how to provide constructive feedback on AI system performance. For IT, cybersecurity, and infrastructure professionals, specialized training on AI-specific security threats and vulnerabilities, Chapter 11. Best practices for securing AI development and deployment infrastructure, on-premises and cloud. Techniques for monitoring AI systems for security incidents, and data protection strategies for large and sensitive AI datasets. For legal, compliance, risk management, and audit professionals, including those with CFE, CPA, IIA, ISACA backgrounds. Focused training on current and emerging AI laws and regulations, methodologies for conducting AI risk assessments like the AI Business Risk Impact Assessment, and audits of AI systems, understanding AI ethics frameworks and standards like ISO IEC 42001, and strategies for managing AI-related legal, compliance, and reputational risks. For procurement, vendor management, and third-party risk teams, training on how to effectively assess the capabilities, security posture, and ethical practices of AI vendors, understanding key AI-specific contractual clauses, e.g., data ownership, liability transparency, and best practices for managing risks associated with third-party AI solutions or data. For executive leadership and board members, strategic briefings on the transformative opportunities and significant risks presented by AI, best practices in AI governance as per ISO IEC 38507, and ethical leadership fostering an AI-ready and innovative organizational culture and their oversight responsibilities concerning AI. Dedicated AI ethics training. Content. A deep dive into universal and organization-specific ethical principles for AI such as fairness, transparency, accountability, non-maleficence, human autonomy, practical methods for identifying, measuring, and mitigating algorithmic bias, ethical decision-making frameworks applicable to AI scenarios, analysis of real-world case studies highlighting ethical AI failures and successes, and a thorough understanding of the organization's specific ethical AI guidelines, review processes, and ethics committees. Objective: to instill a strong ethical foundation and critical thinking skills for all individuals involved in the life cycle of AI systems, from conception to operation and oversight. Comprehensive data literacy and data governance training for AI. Content: emphasis on the critical importance of data quality, integrity, and representativeness for building effective and fair AI models. Best practices for ethical data collection, understanding and mitigating data bias at the source, stringent data privacy and security requirements for AI datasets, standards for data labeling and annotation, and clarifying roles and responsibilities within the organization's data governance framework as it pertains to AI. Objective: to ensure that all relevant employees understand the pivotal role of data in AI and are equipped to manage and use data responsibly and effectively in AI contexts. AI security awareness and threat-specific training. Content raising awareness about security threats that are unique or particularly potent in the AI domain, e.g., data poisoning, adversarial attacks, model evasion, model stealing, membership inference. Training on secure practices for handling AI models, training data, and sensitive outputs. Clear procedures for reporting suspected AI security incidents. Objective: to significantly enhance the organization's overall security posture against attacks targeting its AI assets and infrastructure. Measuring effectiveness and impact of AI training. It's crucial to measure the effectiveness of these training programs, tracking completion rates and conducting knowledge assessments. Monitor who completes training and assess knowledge retention. Gathering participant feedback surveys. Collect feedback on relevance, quality, and impact of training. Observing and assessing behavioral changes. Look for evidence of more responsible AI practices and adherence to compliance. Evaluating impact on AI project outcomes and risk reduction. Indirectly, effective training can contribute to more successful, ethical, and secure AI deployments and reduce AI-related incidents. Internal training for AI use is a continuous and evolving strategic imperative, not a one-time event. It's an essential investment for any organization aiming to leverage AI responsibly, mitigate risks, and empower its workforce. Auditors, including those guided by ISACA and IIA principles, play a key role in assessing the adequacy, relevance, and demonstrable effectiveness of these internal AI training programs as a critical component of a robust AI governance framework. This comprehensive planning and design are what set the stage for effective AI auditing. Thank you for watching, and as always, continue learning, stay curious, and we'll see you next video.